So we have a live audience today. Special thanks to 3A, and thank you to all my subscribers. So, writing formulas from names. So before we looked at if you were given a formula, how would you come up with a name for the formula? Now we're looking at if you're given a name, how do you come up with a formula? So the first question I want you to ask yourself is, does this look like an ionic compound or a molecular compound? And then if it looks like an ionic compound, you just write the ions, you need to have their charges, and you crisscross the charges and reduce. If it looks like a molecular compound, the prefixes are going to tell you how many atoms of each type you have. So first one, we look, calcium nitrate. This should look like an ionic compound. We see calcium, it's a metal. Once we see a metal, we're like, oh, that's an ionic compound. We also see nitrate. Nitrate is a very common polyatomic ion. So we're going to write the ions. Calcium, you're going to look on the periodic table. You'll find calcium's in group 2. So you say, oh, calcium is going to form a +2 ion. And you write that. Nitrate, you're going to have that memorized, and that's NO3 minus. And then you crisscross, and you get calcium with a 2 outside the parentheses of nitrate, of the NO3. Be careful with that. Next one is chromium 6 oxide. If you see a Roman numeral like that, it's going to be an ionic compound. There are some older systems of naming that might use a Roman numeral, but anyway, this is going to look like an ionic compound. So you say, okay, chromium 6. Since you have a Roman numeral, you don't need to look at the periodic table. You don't need to find the charge because it's right here. That means this is chromium +6. So you write that. And then we do oxide. So this is not a polyatomic ion. You just find oxygen on the periodic table. It's group 16. You have a -2 charge. You predict a -2 charge. All right, so we see a +6 and a -2. You could just do the math in your head. If we crisscross, we'd have Cr2O6, but since they're both even numbers, we're going to reduce them. And it'd be Cr2O3. Next one is diphosphorus tetraoxide. And this should look like a molecular compound. Number one, because you have prefixes. We see prefixes on both of the words in this name. Another reason this should look like a molecular compound is that phosphorus is on that right side of the periodic table. Phosphorus is a nonmetal. Oxygen is a nonmetal. And when we see 2 nonmetals, that's how we're going to be naming these. So these are easy. Prefixes tell you how many. So, nope. No ions. Just P2O4. People don't get those wrong as long as they know the prefixes. Next one, silver phosphate. Okay, so this silver's a metal, so this should look like an ionic compound. Phosphate is a polyatomic ion. Again, an ionic compound. So you write the ions. Silver, you notice there's no Roman numeral written for silver. So you find it on the periodic table. That's in that triangle that I talked about. And you know silver is going to be +1. Phosphate is another ion you need to memorize. And we've got a +1 and a -3, so we crisscross. And it's Ag3PO4. I don't know if that got cut off. Next one, nickel 3 carbonate. Again, we see the Roman numeral, looks like an ionic compound. We also see it's nickel. Nickel is a metal. So metal and a polyatomic ion, it looks like it's an ionic compound, so we need to write the ions. So we've got a 3+ and a 2-, and we crisscross. Ni2CO3 with a 3 outside the parentheses. Nickel 3 carbonate.